Question number 46. Consider the following statements. In the first statement, we have bond order of CO and N2 is same. So students, CO and N2 are both isoelectronic and both of them have the same bond order equal to 3. So the first statement is correct. Let us look at the second option now. O2 plus is more stable than O2. Students, we have O2 having a bond order equal to 2 and we have O2 plus which is having a bond order of 2.5. So students, the second statement is also correct. If you look at the third statement now, bond order of CO plus and N2 plus is same. Students, this statement is incorrect. The bond order of CO plus is equal to 3.5, whereas the bond order of N2 plus is equal to 2.5. Let us look at the fourth statement now. MOT explains the diamagnetic character of oxygen. Students, this statement is incorrect. O2 is not diamagnetic, it is paramagnetic in nature because of the presence of unpaired electrons in the pi star molecular orbital. Okay, so this statement is also incorrect. Let us look at the fifth statement now. HOMO, which is the highest occupied molecular orbital of F2 molecule, is sigma star 2pz. Students, this statement is incorrect. The HOMO of F2 is pi star 2px equal to pi star 2py. So the examiner seems to be interested in knowing about the correct statements, and we can see that the correct statements are only 1 and 2, which is given in option 4. So students, we have to select option 4 as the correct answer to question number 46. Let us look at the next question. Question number 47. If 1 liter solution of 1 molar NaCl is mixed with 1 liter solution of 1 molar CaCl2, what will be the boiling point of the final solution? We have to assume 100% ionization of NaCl and CaCl2 in the solvent and the molarity equal to molality. It is also given to us that the Kb is equal to 0.5 Kelvin per molal and the boiling point of the pure solvent is 400 Kelvin. If we talk about the effective number of ions which are present in the system after mixing of both of these solutions. So initially we had 1 liter of 1 molar NaCl and we had 1 liter of 1 molar CaCl2. Now when they are mixed, the total volume shall be equal to 2 liters. So the concentration will be equal to half times this value. So we have C of NaCl is equal to 0.5 molar and we have C of CaCl2 is equal to 0.5 molar as well. If we talk about the concentration of the ions which is produced, we can have I into C effective is equal to I1C1 plus I2C2. So NaCl has an I of 2, the concentration was 0.5. And if we talk about CaCl2, it has an I equal to 3 and the concentration was also 0.5 again. So solving this expression, we have the value equal to 2.5. Now, if we talk about the delta TB, the delta TB value is given by I into C effective into Kb. Now, putting values of Kb and IC effective in this expression, we have 2.5 into 0.5, which gives us a value equal to 1.25. Now, students, the elevation in boiling point is 1.25 degrees C or 1.25 Kelvin, whatever may be the case. So, if the solvent boils at 400 Kelvin, due to addition of these solute, we'll have the solvent boiling at 401.25 Kelvin, which is correctly represented in option 4. Let us look at question number 48 now. A half cell is connected with SHE during the course of the reaction. pH of SHE is increased. The connected half cell behaves as. So students, if we talk about the SHE now, it is mentioned to us that the pH of SHE is increased. It must mean that the H plus ions are getting consumed. So if the H plus ions are getting consumed, it must mean that the SHE shall have this reaction going on. H plus plus electron giving us half H2. So it must mean that the SHE is acting as a cathode. So the other half cell must act as an anode, which is given in the first option. So students, we have to select option 1 as the correct answer to question number 48. Let us look at the next question, question number 49. A mixture of carbonic acid and oxalic acid were dissolved in water to make a 1 liter solution. So 200 ml of this solution required 100 ml of 0.1 molar NaOH for complete neutralization, and another 200 ml of the same sample required 40 ml of 0.1 normal KMnO4. Identify the incorrect statement. So if we talk about the 200 ml sample which the examiner seems to be interested in, so we can assume that the 200 ml sample has X millimoles of H2CO3 and it has Y millimoles of H2C2O4. Now, if we talk about the reaction with NaOH, so NaOH is going to react with both of these species. So we have the MEQs of NaOH equal to MEQs of H2CO3 plus MEQs of H2C2O4. So we have 2 into X plus 2 into Y is equal to 100 into 0.1. So this can be simplified to give us a value of X plus Y equal to 5. And if we talk about the second experiment, which is carried out with KMnO4, only H2C2O4 is going to react with KMnO4. So for experiment 2, we have 2 into Y is equal to 40 into 0.1. Since the normality is already given to us, we need not include the N factor of KMnO4. So this on simplification will give us a value of Y equal to 2, which is the second expression. So on using 1 and 2, we can get the value of X, which is equal to 3. So students, if you look at the options now, KMnO4 reacts with only H2C2O4. This statement is correct. NaOH reacts with both H2CO3 and H2C2O4. This is correct, students. If you look at the third statement now, mass of H2C2O4 is equal to 0.05 grams. So if we talk about H2C2O4 in 200 ml sample, we had already calculated the millimoles, that was equal to Y. And if we talk about the molar mass, H2C2O4 has a molar mass equal to 90 grams. So the mass of 2 millimoles of H2C2O4 is going to be equal to 180 milligrams or 0.18 grams. So students, we can clearly see that the third statement is incorrect and we have to select this option as the correct answer to our question. Let us look at question number 50 now. The working of a Cottrell precipitator is based on. So students, if we talk about a Cottrell precipitator is used in the electrostatic charge neutralization of smoke and dust particles from the waste gases. What happens is this waste gases or smoke consist of colloidal particles, and these are passed through an apparatus which is called as the Cottrell precipitator, which consists of two plates having the opposite charge as the charge present on the smoke particles. So when the smoke particles come in contact with the two plates, it leads to the coagulation of the charged particles and the smoke is thus filtered. So looking at the options, we have to mark option 4 as the correct answer to this question.